It started with a flicker, just a faint blip in the data streams pouring in from telescopes around the globe. Something cold, silent, and impossibly fast was slicing through our solar system in a way that defied every expectation we'd built over decades of stargazing. On July 1st, 2025, the Atlas Survey Telescope in Chile, part of a network designed to spot potentially hazardous asteroids before they catch us off guard, picked up the anomaly. At first, it seemed like just another distant speck in the night sky. But as astronomers crunched the numbers, the truth emerged. This wasn't a routine rock tumbling through space. NASA quickly confirmed it, designating the object as 3I/ATLAS, the third confirmed interstellar visitor to our cosmic neighborhood. Unbound by the sun's gravity, it was hurtling in from the vast emptiness beyond our solar system at a staggering 130,000 miles per hour, faster than any natural object we've ever tracked in these parts. And the most chilling part? Its trajectory wasn't random. It was precise, almost deliberate, as if it had been aimed right at the heart of our planetary domain. For years, we've gazed into the stars, assuming the universe was a quiet, indifferent void. But now, with this enigmatic intruder barreling through our backyard, the James Webb Space Telescope, JWST, has locked onto it, unveiling details that challenge everything we thought we knew. Stick around as we dive deeper into this mystery, because what if this isn't just a passing rock? What if it's something far more profound, something that could rewrite humanity's place in the cosmos? Imagine the thrill rippling through observatories worldwide when 3I/ATLAS was first flagged. The ATLAS system, short for Asteroid Terrestrial Impact Last Alert System, is a NASA-funded powerhouse with telescopes in Hawaii, Chile, and South Africa, scanning the skies relentlessly for threats. On that fateful day in July 2025, it captured images of an object that didn't belong. Initial observations showed it moving at hyperbolic speeds, meaning it's not orbiting the sun like our local asteroids and comets, but slingshotting through on a one-way ticket from interstellar space. According to NASA's Jet Propulsion Laboratory, its excess velocity clocks in at about 58 kilometers per second, translating to that mind-blowing 130,000 miles per hour. That's faster than the Voyager probes we've launched, which have been cruising for decades to reach the edge of our system. Simulations tracing its path backward point not to the Oort cloud or the Kuiper belt, the distant reservoirs of icy bodies in our own backyard, but to the infinite darkness between stars, possibly originating from the direction of the galactic core or even another star system entirely. This wasn't some remnant from the solar system's birth 4.6 billion years ago. It was a cosmic nomad that had wandered the Milky Way for potentially millions of years, undetected until now. And here's where it gets intriguing. Before 2017, humanity had never spotted a single interstellar object. Then came ʻOumuamua, followed by 2I/Borisov in 2019, and now 3I/Atlas in 2025. Three in less than a decade. Is this a coincidence, or are we on the cusp of discovering that our solar system is a busier thoroughfare than we ever imagined? Keep watching, because the patterns emerging could signal something monumental. As the news broke, scientists didn't waste a second. They mobilized the most advanced tools at our disposal, including the James Webb Space Telescope, humanity's $10 billion eye in the sky, launched in 2021 and positioned a million miles from Earth. JWST, with its massive 21-foot gold-coated mirror and infrared instruments, was built to peer back to the universe's infancy, capturing light from the first galaxies formed after the Big Bang. But in August 2025, mission controllers at NASA's Goddard Space Flight Center redirected its gaze closer to home, onto 3I/ATLAS, as it hurtled toward its perihelion, the closest point to the sun, expected around October 30th, 2025, at about 1.4 astronomical units, roughly 130 million miles away. On August 6th, 2025, JWST's near-infrared spectrograph, NIR-SPEC, zeroed in, analyzing the object's light signature for clues about its composition and behavior. What they found was puzzling. The object's brightness didn't align with initial size estimates from Hubble Space Telescope observations, which pegged its nucleus at around 0.6 to 1.2 miles across, relatively small for such a bright reflector. Typically, comets or asteroids reflect sunlight based on their surface materials. Dusty rock or ice scatters light diffusely, but 3I/ATLAS shone with an intensity suggesting a highly reflective surface, perhaps metallic or crystalline in nature. Ground-based telescopes like Gemini North in Hawaii and Gemini South in Chile captured images showing an emerging tail at least 35,000 miles long and an expansive coma, a hazy envelope of gas and dust, indicating cometary activity. Yet spectral analysis revealed unusual abundances of carbon dioxide and nickel, elements not commonly dominant in our local comets. Harvard astrophysicist Avi Loeb, famous for his bold theories on ʻOumuamua, stepped into the fray once more. In a July 2025 paper co-authored with colleagues, Loeb urged the community to scrutinize for non-gravitational accelerations, subtle shifts in trajectory unexplained by solar gravity or outgassing. If we detect deviations that can't be attributed to natural processes, Loeb argued in interviews, we must consider the possibility of artificial origins. Could this be a drifting rock or something engineered? The questions are mounting, and as we unpack them, you'll see why this discovery has astronomers on the edge of their seats. To grasp the gravity of 3I/ATLAS, we need to rewind and examine its predecessors, the interstellar pioneers that paved the way for this enigma. Back in October 2017, astronomers using the Pan-STARRS telescope in Hawaii spotted 1I/ʻOumuamua, the first confirmed interstellar object. Shaped like a cigar or pancake, roughly 800 feet long, it tumbled through our system without a visible coma or tail, defying comet classifications. Its speed? About 59,000 miles per hour at closest approach, with a hyperbolic trajectory that slung it past the sun and back into the void. But the real head-scratcher was its acceleration post-perihelion, a slight boost that couldn't be fully explained by solar heating vaporizing ice. No gas plumes were detected, leading some, including Avi Loeb, to propose in his 2018 book, Extraterrestrial, that it might be an artificial probe, perhaps a light sail propelled by radiation pressure. Skeptics countered it was likely a hydrogen iceberg or fragment from a disrupted planet, but the debate raged on. Then in August 2019, amateur astronomer Comet Borisov discovered 2I/Borisov using a homemade telescope in Crimea. This one was unambiguously a comet with a bright tail of carbon monoxide and water ice, zipping in at 67,000 miles per hour. It fragmented as it neared the sun in December 2020, offering a treasure trove of data on interstellar chemistry. Borisov was larger, about half a mile across, and its composition hinted at origins in a distant star system, possibly similar to our own. Now, fast forward to 2025. 3I/ATLAS blends elements of both. It shows cometary features like a tail and coma, yet its high reflectivity and chemical oddities, abundant CO2 and nickel, as revealed by JWST and ground observations, echo ʻOumuamua's mysteries. Its trajectory is steeper, with an inclination of about 45 degrees to the ecliptic plane, suggesting it plunged in from above the solar system's disk. And that speed, 130,000 miles per hour, makes it the fastest yet, implying a more energetic ejection from its home system. With each visitor, the anomalies stack up. Are these isolated wanderers or harbingers of a galactic migration? As we explore further, consider this. The rate of detections is accelerating, coinciding with our technological leaps. Is the universe revealing itself, or are we finally equipped to see what's always been there? Don't stop now. The real twists are just ahead. Delving deeper into the science, let's break down what makes 3I/ATLAS so captivating. Orbital mechanics tell us it's on a hyperbolic path with an eccentricity greater than 1, meaning it'll swing by the sun and exit the solar system forever, unbound and free. Calculations from the Minor Planet Center show its inbound velocity at infinity was around 58 kilometers per second, a value that places it among the fastest moving objects in our vicinity. For context, that's over twice the speed needed to escape Earth's gravity from the surface. As it approaches perihelion on October 30th, 2025, solar heating is ramping up its activity. Recent images from the Gemini telescopes show the tail elongating and the coma brightening, releasing gases at rates that could explain some trajectory wobbles. But not all. Early data from JWST's August 2025 observations detected unexpected infrared emissions, stable patterns that don't fully match typical cometary outgassing. In a press release from the European Space Agency, ESA, collaborating on JWST, scientists noted surprising chemistry, including higher than expected nickel levels, which could indicate formation in a metal-rich environment or even exotic processes. A.V. Loeb, in his Medium article from August 23, 2025, posed a provocative question: should we be happier if 3I/ATLAS is a comet? He argues that dismissing artificial possibilities out of hand stifles scientific inquiry. In a debate with skeptic Michael Shermer on YouTube in September 2025, Loeb elaborated, the non-gravitational force on Oumuamua was consistent with solar radiation pressure on a thin structure. For 3I/ATLAS, if we see similar deviations without visible emissions, we must entertain engineered scenarios. Critics like Jason Wright from Penn State caution in his July 2025 blog that Loeb's speculations often outpace the data, but even they admit the object's weirdness warrants close scrutiny. As observations continue, with Hubble estimating its size and ground arrays like the Very Large Telescope in Chile tracking its spin, the puzzle pieces are assembling. What if these deviations hint at internal mechanisms? A natural nuclear reactor, as Loeb speculated in an August 2025 New York Post article, or something more? The intrigue builds with every data drop, pulling us toward revelations that could shatter our worldview. Hang in there. The implications for humanity are profound. Beyond the raw data lies a shadow of speculation that's impossible to ignore. The what if that keeps astronomers up at night and viewers glued to their screens. Remove the conventional explanations. The brightness too high for its size, the chemical profile atypical, the acceleration subtle yet persistent. What's left? The whisper of artificiality, not little green men in saucers, but perhaps a relic from an ancient civilization, a probe, a derelict craft, or even a message in a bottle from the stars. Loeb's July 2025 paper, Is the Interstellar Object 3I/ATLAS Alien Technology, co-authored with Harvard colleagues, outlines scenarios where the object's reflectivity suggests a manufactured surface, possibly a solar sail or metallic hull. He points to its trajectory, aimed not at random but passing close enough for detailed study, as if inviting observation. In a Fox 10 interview on August 24, 2025, Loeb noted, it's moving toward the inner solar system with precision. If it's natural, fine, but let's not assume. This echoes his ʻOumuamua theories, where he suggested we might have missed a signal. For 3I/ATLAS, JWST's thermal scans show patterned heat distribution, hinting at asymmetry or internal structure. Electromagnetic fluctuations, faint but detectable, could indicate cavities or tech remnants. National Geographic's September 2025 article highlights how its age, potentially one of the oldest objects we've encountered, based on its velocity and composition, fuels ideas of it being a cosmic fossil. If artificial, it implies a sender from a star system perhaps thousands of light years away, a civilization that mastered interstellar travel eons ago. The terror isn't invasion, it's the realization we've been oblivious. In a 13.8 billion-year-old universe, solitude was comforting. But if we're not alone and they've been watching, that's the chill that runs deep. As we approach the climax of this tale, ask yourself, are we ready for the answer? As weeks turn to months post-discovery, the narrative around 3I/ATLAS took a darker turn. Initial transparency from NASA and ESA, releasing orbital plots and preliminary spectra, gave way to a peculiar reticence. By late August 2025, updates on mission pages slowed. Raw JWST data requests were met with internal review delays. Journalists filing Freedom of Information Act (FOIA) requests received redacted files, fueling online buzz. Whispers from insiders at observatories suggested reassignments. Key researchers pulled, telescope time reallocated. Why the shift? Speculation abounds. In a Reddit thread from July 2025, astronomers debated whether classified findings, perhaps anomalous signals or structures, prompted intervention from defense agencies. The U.S. Space Force, established in 2019, monitors near-Earth objects for security threats. Could 3I/ATLAS trigger protocols? Loeb, in his Medium post, warned of astroarchaeology being stifled by bureaucracy, urging open data. Meanwhile, public fascination exploded. YouTube videos dissecting the object garnered millions of views, with titles like, "Is 3I/ATLAS an alien probe?" The Debrief's September 2025 article noted, "The more we watch, the weirder it gets," citing growing tail anomalies and velocity tweaks. Government silence only amplifies the mystery, turning a scientific event into a global thriller. What are they hiding? Or is it caution, ensuring facts before frenzy? Either way, this veil draws us in, compelling us to seek truth amid the shadows. Now, as 3I/ATLAS glides silently onward, a profound realization dawns. This is an inflection point in human history. Our telescopes, once tools for distant wonders, now confront the immediate unknown. If natural, it's a rare glimpse into galactic diversity, a comet forged in alien stellar nurseries, carrying clues to universal chemistry. If artificial, it upends everything. Proof of extraterrestrial intelligence. Perhaps extinct, sending echoes across the void. Loeb's mantra: extraordinary claims require extraordinary evidence, but the evidence is mounting. JWST's ongoing monitoring, combined with missions like ESA's Comet Interceptor, set for launch in 2029, potentially adaptable, could provide closure. Yet the broader implication lingers. Our tech boom, AI, quantum computing, Mars ambitions, coincides with these visitors. Is it chance or a test? As National Geographic posits, perhaps we're the experiment, our reactions observed. The scariest thought: we've never been the watchers. We've been the watched, only now awakening. JWST, meant for cosmic origins, instead mirrors our ignorance. We've entered a new era where stars aren't just lights, they're potential eyes. Amid this escalating enigma, a disquieting undercurrent spreads through hushed forums and encrypted chats. What if 3I/ATLAS's arrival was timed? Not random drift, but calibrated to our readiness. Billions of years silent, then visitors as we deploy JWST, harness AI for anomaly detection, and probe exoplanets. Loeb's September 2025 debate with Shermer explores this. It's like a cosmic Rorschach test. What we see reveals us. If a probe, its silence might be deliberate, awaiting our move. Do we signal, study, ignore? The void staring back isn't empty. It's expectant. This isn't just astronomy. It's philosophy, psychology, destiny. JWST was engineered for the ancient and vast, yet it uncovered the proximate and possibly sentient. An object too refined for chance, too hushed for normalcy, too opportune for accident. We sought answers, found questions. Are we isolated, observed, advanced enough? This Voyager heralds a lexicon of the unknown. Artificial or arcane, it demands we evolve. The cosmos isn't indifferent. Perhaps it's attentive. If this tale ignited your curiosity, subscribe for more uncharted frontiers. Hit notifications. The next visitor could redefine us. Share with skeptics. Comment, natural or more. Let's unravel together.